Alrighty, today we're going to be learning about quadratic domain and range. We should be on pages 12 and 13. 12 is over here. That's what we'll do tomorrow in class. And today in the notes we're going to do page 13. So let's zoom on in so we can see it. So domain and range isn't different, but quadratic, domain is still, the domain is still my list of values that I am allowed to use for my x, so that I'm allowed to put in my allowed input. So my allowed input values, and my range is my resulting output values. So what I put in determines what I get out. So I have to figure out what values I'm allowed to put in, and that tells me what values I'm allowed to get out. So that hasn't changed. That hasn't changed at all. But what has changed is what our graph looks like. So that changes what the range is going to look like on a quadratic function. Okay, so again, we're still using Dr. XY. Our domain is our x values, and our range is our y values. Okay, so when we talk about domain and range, we're going to start by, I believe when I taught you this last time, I taught you about boxing things out. Okay, so when I look at these functions, I'm going to try and box it out. Now remember, our rules are: 1, you cannot box an arrow. Okay, so I cannot box out an arrow. And again, if this doesn't make sense, you know, that's fine. If I don't see a bubble or arrow, it's a dot. Okay, we consider it to be a dot, and that means we include it. So this one will be like that. Do you see what I'm saying? So if I don't see a bubble or an arrow, I assume that it's a dot. So like right here, I don't see a bubble or an arrow, so I'm going to assume that that thing is a dot. Okay. Again, hopefully we'll get back to that in a second and it'll make sense what I'm saying. Okay, so I'm going to try and box this in. All right, so what I'm going to do is I'm going to look over here. I can't box right here, so I can't box here or there because those are arrows and I cannot box out an arrow. But down here, I don't see an arrow and I don't see a bubble, so I can actually box, see, all of that right there. Okay. So I'm boxing all of that out, meaning those are not values that I'm going to be using. Oh my gosh, seriously? This thing is driving me crazy. Okay, hold on, let me adjust the focus because I apparently looked at it wrong and now it's all mad at me. I'll pause it and get that. Okay, that's better. All right, now notice, like I said, I cannot box out anything over here because, again, so if you're not sure if you can box it, you want to do the smoosh thing. I don't know if y'all remember smoosh, but here's what it is. You're going to take your whatever endpoint you see, and you're going to push it down to the x-axis, and you're going to take this one and push that down to the x-axis. Okay, and that's what my x values look like. They look like that. Okay. Is there any limit in either direction on that function? No, because it says this is going to keep going forever right, and it's going to keep going, it's going to keep getting bigger and smaller until infinity. So this means I can use any x value that I want. All right. What about the range? Let's look at that. My range, so I do have an endpoint here. So I've got an arrow up here. I definitely see that arrow up there. But down here, it doesn't go past this point. Because remember, I've got my vertex, I've got my turning point. So it's going to go down, 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 down to -5, and then it's going to whoop, it's going to turn right back around and go the other direction. So because it turns around, when we had linear functions, if I could put in any x, I could get out any y. Quadratic functions aren't the same thing because my quadratic function, it's going to turn around. And since it turns around, that means that at some point, either at the minimum or at the maximum, at the lowest point or the highest point, it's going to turn around, and then I'm going to have to go the other direction. and it's not gonna keep going in that direction anymore. So if I look at this one down here, since I don't see a bubble or an arrow, I put a dot and I connect that up. Well, if I were to draw that, my y values look like that. And the lowest value I see is -5. So that means anything -5 or up I can use. I can use any value -5 or higher. All right? So how would I write that? Okay? Well, how do I write any number? Well, we write that as all real numbers, or fancy R, or ARN, whoopsie, let me move that a little bit, or ARN. We write it as all real numbers because that means I can put anything into this function. Even though I can put anything in, I can't get any y value out because all the y values I have are -5 or higher. So my y values are bigger than -5 or equal to -5. Okay? So that's how I'm going to write my domain and range. Now, we're going to be doing word problems tomorrow, so it's important that we, well, I guess Monday, we're going to be doing word problems on Monday, so it's important that we also be able to figure out if something is discrete or continuous. Now, the big confusion that I tend to see with kids is with discrete and continuous, you're like, oh, if it's continuous, discrete you get fine, it's dots. So like if I go over to this side, this graph, it's all dots. That means it's discrete. But what y'all end up thinking though is you're like, oh, but this one is not continuous. You think it's not continuous because it doesn't continue on forever. Remember, continuous does not mean continues on forever. Continuous means connected. Okay, so let's jot that down over here. Okay, discrete is dots. Okay, continuous is connected. Now, knowing that, let's look up here. Is this disconnected or connected? Is it dots or connected? This graph here. Well, it's connected, so that means it's continuous. All right. Now, if I look at this graph, this is kind of, this seems to, I feel like this is going to throw you off only because they're giving you a graph. If they gave me a function to go with this, you'd put f of x equals whatever that function is, you put f of 0 in the calculator, and it'll tell you, okay? But since they didn't, that's what's going to throw you guys off. So I'm going to show you a way that you can kind of organize this to kind of help you out. All right, so if you write f of x equals y, okay? For this one, they say f of 0 equals something. Which column is this in? This is the x column. So that means they're giving me an x of 0. Well, when x is 0, what's y? Well, when x is 0, y is -5. So f of 0 is -5. Okay? Same thing here. When f of x equals 2. In that case, they're giving me a y value because they gave me something in the y column. I have to figure out what that x value is. So let's look. Okay, if I look right here, well, when x is -2, I'm sorry, when y is -2, I've got two x values. I've got, looks like -1 and +1. -1 and 1. All right. So again, and then what is the, and you know, just to put it out there, what is our most important value? You guys should be able to tell me what is the most important thing, the thing that we look at first on one of these graphs. We look at the vertex. Okay. Well, my vertex is 0. Okay, that's not even readable. 0, -5. Okay, it's right there at 0, -5. And my vertex tells me two really important pieces of information, okay? It tells me my axis of symmetry, which is x equals 0. It tells me that I have a, since it's pointing up, it tells me I have a minimum value of -5. And notice that minimum value is also my range. So it tells me that my y values all have to be bigger than or equal to -5. All right, so I get so much information out of that vertex. It tells me what my domain, it tells me what my range is. It tells me what my minimum or maximum is. It tells me my axis of symmetry, so I know exactly where I'm folding. All right, so if I were to write that down, again, I would say I have a minimum value right here, minimum of -5. All right. I want you to pause the video and I want you to try to find that same information. I'm going to zoom out a little bit so you can see this. For the second one, I want you to box it out, draw your domain, and draw your squishing, do all the same stuff that I just did. So pause the video right now and I want you to try that. All right, so I'm going to do it now. So I can see, again, I've got arrows. So let's just do that here. I've got arrows. Looks like maybe like right there to right there. Yeah, I think that's -4 to +4. But they're arrows, right? So do I care what they are? No, because they keep going. So again, my domain looks like a line with arrowheads at both ends. That means I can use any value, okay? My range starts up here at 9, and it's got an arrow down there. So I can block off anything. I can box out anything bigger than 9 because I can't use anything bigger than 9. Okay? So this one, my range, looks like -9 and down. -9 and less. Okay? So if I write that, remember, anytime I see anything, it's a line like this. Anytime there's just arrows going every direction, that's going to be all real numbers. All right. When I see my range here is -9 and down, that means the values I want, the y values I want, are less than or equal to -9. And I said or equal to because I don't see a bubble here, then I can include it. All right. I'm connected on this one. So again, we said discrete is dots, continuous is connected. Since it's connected, we have continuous data. All right. Make my little table here. F of x equals y. Okay, so f of 1 means they gave me an x value of 1. If I go over 1, the y value that goes with it looks like it's 8. Okay. They said f of x equals 9. Okay, when they say f of x equals 9, well, I only see one value there, and that's when x is 0. Real quick, tell me why is there only one value? Okay, the reason there's only one value, because what is that point up there? It's my vertex. It's my most important guy. It's at 0, 9. So if you're asking me, that's the only value I'm going to give that you can give me that does not have 2. That's the only y value you can give me that doesn't have 2 x's to go with it, is my vertex. Okay? Remember, my vertex is going to tell me my axis of symmetry. It's going to tell me that I have a max value of 9. And that's a positive 9. I'm sorry, I screwed that up, y'all. And it's going to tell me that my range is y is less than or equal to 9, which I already knew, except I made a typo there. Sorry, you can make a mark tomorrow. I'm just going to erase that, pretend it didn't happen, even though we all know it did. Okay? So write down your questions about that. Let me know what I need to go over, and we'll talk about it tomorrow.